And want to introduce our first presenter, Thierry Faudier from Harmonic. Thierry is the current president of the Ultra HD Forum. That's the global organization responsible for promoting market adoption of ultra high definition. And he's vice president of video strategy at Harmonic. So he's in charge of defining and driving the execution of the long-term strategy of Harmonic's video business, and he's also co-chair of the MPEG Roadmap Committee. And with that, I'd like to hand over to Thierry. Thank you.
Thank you very much. Thank you. So today I'm going to explain or to share with you what we see happening in the on one hand on the video market, and on the other hand on how we can help the video market to grow with the cloud technology. So I will go through some introductions, some definition, because I think we need to set the stage when we talk about video especially. Then we are going to share some of the computation models we have developed for this presentation and this paper. And then, more important, implementation example. I know a lot of people have seen, have heard, but we want to share real example, and also open a bit the discussion on what we think is going to impact our market with technology such as elastic encoding and some conclusion. So first, this is a study on what is the impact of the codec complexity on software infrastructure. So we are going to focus on live. And as you probably know, file uses other techniques such as Netflix, which is basically using multiple paths and making a priori decision, which is completely different from what you do in live, where you have to make on-the-fly decision. Then this is pretty much a future-looking presentation. We're going to look at UHD 1, UHD 2, for those who don't know, it's 4K, 8K, but also new codec. And you have heard presentation yesterday about what is happening. I didn't list them all. I take AV1 and VVC because they are easy to model in terms of complexity. And of course, this is based on real-life data. So in order to define the compute space for encoding, we have looked at definition of appliance, so fixed function compute box. Software is executable that can run on a variety of hardware platform, and cloud elastic compute resource managed by an orchestrator. And of course, the performance are different. One is limited by the hardware capability. One is limited by the ability to use all the hardware resources. And one is limited by the performance, only limited by the node availability. Basically, the sky is the limit, and probably that's why we call it cloud. So in terms of compute and appliance, you have a certain amount of CPU. Some appliances are multi-CPU, 2 CPU. That's what the industry is using. Some are 4 CPU, which is a bit more complex and also more expensive. And then we also see appliance mix and match of CPU and GPU. On software, of course, the goal is to be able to map those appliances into a software model. So the software is going to execute on each of those appliances. And then the cloud is pretty much what we see on the appliance space, except that it's not only one appliance, it's one node that can be multiplied by n, being a dual CPU, quad CPU, or mix of CPU and GPU. So just to give you one example, and this is not an advertisement, this is just to show you in our company what we have developed in terms of compression engine, in terms of application, how is it orchestrated, what type of cloud platform are we using, and you see we are quite agnostic since we can go across multiple platforms. So we have in our platform VOS the capability to address all the different approach, the software as a service, the very bare bone software VOS engine, and the software cluster, which is something which is more in the private cloud architecture. So let's look at the definition. So we take the SD, for those who don't remember, that's what has been created in the 90s. HD, which is basically 4 times more pixel, UHD 1, which is the ITU definition of 4K, and UHD 2. And you see the number of pixels is quite increasing. From SD to UHD 2, we are already at factor 32. So here we try to put on a map what is the ratio of complexity compared to an SD AVC encoder that we are going to compare to a HD AVC that we compare to an HTVC implementation. So you see the complexity is multipliable by 4. Then we take the AV1 with the current version of AOM, you go factor 20, and then VVC is about factor 12, taking the latest version of VVC. So you see, depending on the codec you are going to use, you are going to increase, sometimes dramatically, the amount of compute, which will be one of the challenges the cloud is going to solve. Now, if you look at the resolution between the different codecs, so I take SD, HD, UHD, and UHD2, depending if I use single bit rate, which is the transpose stream delivery, or adaptive bit rate, you see that the amount of compute can move from 1 to 180x, which means that we are in a complete different space when we are going to go across this new resolution. And you'll see in the following slides, if I now mix the resolution with the codec, I can go to up to 2150x, meaning we need to think differently. We cannot bring the old appliance mentality, arriving at 4K and even 4K with AV1. We have to look at different ways to solve the problem. So here, I'm going to tell you the story, which is a true story, is BBC. BBC has decided during the World Cup to transmit UHD across the public network in UK. So the top profile was at 36 megabits per second, down to 7 megabits for the bottom profile. And what we have taken for exactly the same source of content, we were able to apply different techniques. So this was an appliance-based solution. We have tried to apply different techniques, cloud-based with content-aware encoding. For those who don't know, the content-aware encoding is basically applying VBR to the incoming signal and deciding how to go up or down depending on the complexity. And here you see the top bit rate was able to be reduced by 34%. And interesting enough, at IBC, BBC was invited to present the BBC iPlayer UHD trial they had during the World Cup, and they were saying in front of everyone that their target bit rate was 22.5 using new technology. You see, we're not too far. So here you have a typical example where the classical approach gives you a very high bit rate, and the reason the bit rate goes so high is because the resources are limited in the box you are installing in your headend, as opposed to a cloud solution where you have much more capacity and much more modern techniques in order to improve the efficiency. So here you have CPU plus GPU. It's everything in a box. It's extremely compact. On the other hand, what we have done, we have put multiple instances of a dual CPU architecture. Of course, there is more resource. And you will see, you see that the saving is, I think I didn't put that, but I think it's about 39% saving. And if you count that per millions of people, hopefully BBC was only with 50,000 subscribers, that's okay. But if you multiply by millions of people, the bill is going to have a different value. So, conclusion, cloud-based solutions offer a better compression versus a classical appliance approach when the resources are limited. So let's look at UHD HEVC, which is basically what people are doing today. This was the BBC example, and you have normalized to a factor 1. And what would be the complexity if I want to do ABR? So we say it's about 3x in terms of number of CPUs. The node requirements, if I want to change the codec, imagine I'm Netflix and I said to myself, I need to stop paying the HTVC royalty. What is going to be my impact? And then if I am NHK, you probably have heard NHK is going 8K, but of course 8K in HTVC has a certain limitation, although you can demonstrate much more improved quality compared to what is done today. But you see, UHD2 in VVC is going to be a massive tax compared to what you do, factor 50 compared to what you do commercially with HTVC. So basically, it shows you that when you change the codec on a given UHD system, it's going to have a big impact, and you need to be ready for that. So what we have done, and I want to thank our chair for pushing me to show you a real number, we have taken basically an appliance which has two UHD profile, one 1440p profile, and we had one node, so we simulate an appliance. And then we have taken exactly the same content on three nodes, which each node has basically the capability to handle one UHD profile. So you have a two UHD profile per two node, plus one 1440p, which was running. And here, of course, you have more CPU cores, because you have total, I think I didn't put, but 20% more CPU cores. And we are going to look at what is the result comparing those two different approaches. So on the top, you have the appliance, which was encoding the top profile. On the bottom, you have the results out of the cloud encoding. And you see that in terms of quality, one is much more crisper. And in terms of bit rate, we were able to save, using content-aware encoding techniques, 11%. So basically, less bits, improved quality. And that's what you expect to have using only 20% more CPU. So there's, of course, always a trade-off. You cannot create better quality with the same amount of CPU as on an appliance. So here we are going to show you what's the impact of ABR. And of course, ABR is a challenge because it requires more compression capacity. And we have not seen yet mass scale UHD ABR with multi-node implementation. So on the appliance, you see you need to have more servers, so which means you have to put multiple boxes, and this is something people have not been able to use yet. On the cloud, of course, you can put more nodes, which means you can have a more gradual increase in terms of compute. Of course, this has to be synchronized across the multiple nodes. So we think for ABR, the cloud is much more friendly than stacking up boxes, as you can see in this slide. So how the cloud can address increase in the codec complexity? Basically, on the codec side, you see you can do tiling and slicing with our two technologies which have been developed for MPEG. You have the same capability in AV1, so you can decide to slice your video and send that to different nodes. We expect to have the same capability, of course, in VVC. In terms of quality impact, the fact that you tile and slice your video, you will have about 10 to 15% bit rate impact, which means that you have to pay a tax each time you splice your video across multiple nodes. Splitting the input video is possible using tile technology, and each unit is mapped into one node. So, of course, we want to have this capability available from HD to UHD. If you want to increase the resolution, you will be limited by your CPU power, and ABR is, of course, one technique where we already use the multiple profile on multiple nodes. So today, if I want to look back, if you remember my AV1 example here, AV1 is about 10 to 30x more than what I do on UHD. So what we see is that AV1 UHD live is not realistic yet because you'll have to split across so many nodes that is not going to be economical. So that's one example of where you push too much the technology. If you look at the business case, you end up paying too much compared to HTVC. For those who don't know, AV1 is still not able to outperform HTVC in terms of compression efficiency. So let's look at a new concept that was introduced in 2018 by Harmonic, so what we call the efficient cloud-based video processing, and basically is how you can balance the cycles between multiple channels sharing the same CPU nodes. So basically, the goal is to say if this channel is more hungry in terms of CPU resource, you give it more cycles. And if this channel on the same node is less hungry, it can basically balance the node dynamically between the different channels. So you increase your video quality, you reduce the bit rate, and of course, you reduce the CPU usage over a long period of time. Like over time, you will have less CPU used because you can optimize your system. So this is already implemented in our portfolio of products. So this is a typical example where you can use the cloud to do things that you would not do with a very static setting in an appliance. So to conclude, appliance is showing clear limitation in UHD HEVC, even more when you go to next generation codec or more resolution. The cloud is well adapted when the instance is mapped into one node. This is easy to manage, this is easy to handle. ABR is better solved in the cloud environment because you can have multi-profiles on multi-nodes, and you saw the benefit to have a better, even better quality. Of course, the cloud offers the flexibility to partition the video on each node, but this is not very well deployed commercially because of the impact of the video quality and also the fact that you are using too many nodes. It's not very interesting commercially. Elastic encoding, very promising technology, and I mentioned in our meeting that you will see more of those techniques, how to balance the CPU between multiple channels, but you have also option to have more CPU available when the content is more complex or watched by more people. And on the other side, if nobody is watching the content, think about the vacuum cleaner advertisement after midnight, you might want to reduce the number of cycles dynamically. And of course, as you can imagine, my company, Harmonic, is quite committed to deliver the best encoding quality in our VOS platform, which is now powering more than 6.5 million subscribers around the world. So even if I got stolen 2 minutes by our moderator, I still have time for questions. Thank you. Yes? Tap dancing? No? Questions?
Hi, Sean McCarthy from Dolby Laboratories. I was interested in your elastic encoding, and I was curious, what are the things that would make one sequence require more CPUs than another sequence?
Sorry, can you repeat?
So, elastic encoding?
Yes.
I think the principle was that some sequences, or some parts of sequences, would require more CPUs
Yes.
than other sequences. What characteristics are they? Is it motion? Is it texture? Is it?
Yeah, actually, during the encoding process, the encoder is looking at the complexity, and yes, it's motion, texture, and it's basically asking for more cycles.
Okay.
And what you do in an appliance, you try to separate each of the channel has his own CPU budget, and nobody's sharing anything with anyone. Mm-hmm. Now, because you have access to more CPU capacity, you have the luxury to allocate dynamically, and if you have a good software architecture, you can launch seamlessly. Mm-hmm. And when I say seamlessly, it should not disturb anything on the output of the encoder, and therefore you can allocate more CPU even if you want. But yes, it's an internal measurement during the encoding process, mm-hmm. and it's highly related to high motion, high frequencies, fast scene change, random access on a short time horizon. So all the crazy, and Sean, mm-hmm. These are the same recipes. We don't change them because they work.
Okay, thank you very much.
Thank you.
Do we have any more questions in the room? So Thierry, you promised that you do a dance when you finish early, didn't you? So can you tell us what your future plans are? So how is this going, to the next step?
So the next step, for those who are following what happens in the industry, there is this concept of closing the loop between what you measure on the client, what you measure on the CDN, what you measure on the network, and then make educated decision on how to encode the content and how to distribute the content. And here, beyond the elastic encoding, you might say, I'm not going to distribute all those profiles to the subscribers because there are very, very small amount of players who are going to access this content. So we call that network orchestration. And in that case, you are going to make a real-time feedback loop on a chunk basis in order to see how you can better use your resource, encoding, packaging, and CDN caching in order to have the best adaptation to the real-time state of the network, meaning you need to have a lot of probes in real time that are being distributed across the network, and this has to work for the managed service, for the unmanaged service like the OTT providers, and I believe this could be a very good topic for next year, but I will let the jury decide if it's a good story.
What are there also plans? I mean, you looked at high resolution, UHD2 resolution even. Is there any plans for higher frame rate, HDR?
Yes.
No?
Yes, so today, now I take my Ultra HD Forum hat. Today, there is an agreement to do 2160 p60. Some broadcaster would like to do 1080p 100, 120. And as you know, in Japan, they are already in production with UHD2, which is 8K p60. And the problem is the bandwidth, which is very high, and the adoption of TV set, which is very low. So you have an interesting business case where you send a lot of bits to a very limited number of people. I think what is more interested is to send a very small number of bits to a very large number of people, and this is why we have created UHD1, which is so far doing very well with, I think, about 200 million TV set around the world and 150 live channels. So this is where people are today enjoying, hopefully, and very, very little in the cloud yet, but you see the NASA channel, for example, Harmonic is powering on UHD, on the Roku set-top box. I think we have around 390,000 download apps on one set-top box, the Roku box. So this is an interesting experience, and those interested, we can show you on the Harmonic booth. It's a way to deliver the content without breaking the bank with VOD asset, easy to deliver at very reasonable bitrate. Very far from 8K.
Wonderful, thank you. And here we have one question from our president.
Oh my goodness.
Yeah, now you're in trouble. Hi, Terry. It's Pat Griffiths. So some little birdies were whispering to me, we know if you have more CPU cycles, obviously you should get a better result. So a couple of questions for that. Can you give us some indication of the cost comparison? So maybe you get a better compression result. Cloud isn't totally free. It's scalable, but any sense about the relative cost complexity? Not absolute dollars, but...
You mean compared to an appliance or...
Appliance versus cloud.
So what's interesting, if I look at, for example, my company is selling appliance, which is basically a server with software on it. If you go to the cloud, it's a server with software on it. So the bill of material is very often the same. The difference is in the appliance world, you have your own proprietary management system. You want to bring a new server for new functionality. You have to go to IT, procurement, RFP. Everybody gives up. In the cloud environment, you just spin up and down your instances. Yes, it's more expensive than having a fixed function, but it's also much more attractive to launch new services with nearly zero risk. I give you an example. The World Cup in soccer, in some country, everything was racked and stacked for 12 months. In some other country, you had customers who had no infrastructure ready 6 weeks before the event. And those operators were scoring millions of subs and were able to absorb the load just because they could have load balancing with a cloud infrastructure. So BBC had 50,000 subs on a very well-oiled appliance solution as opposed to millions with a cloud infrastructure. So I hope, Pat, I was able to convince you that cloud can be beneficial to launch at scale services.
Yeah, but I heard the word it is more expensive, and you didn't actually elaborate on that.
Yes, because in the model of operators, they say, hey, this is my people, this is my data center, it costs me nothing. Yes, but you cannot scale as much as you would do in the cloud. So I think the two approach can live, but if you ask me, looking forward 5 years from now, there will be a lot of infrastructure in the cloud just because you have new resolution, new codec, new business model, marketing people breathing on your neck, Netflix starting to impact your model. You have Disney Plus, you have Apple, a lot. All those people are on the cloud, and you want to compete with them with a very static view of the world. You have seen Nokia, BlackBerry, Motorola die just because they were building a phone. And Apple, Google were building an IP device. And think about this. I hope I will convince you with my final comments, like they say at the Democrat debate.
Well, let's keep politics out of it. We're technologists
It's a good
here.
one. I had to make one political joke.
But your points, my takeaway is your point, you can get better performance, better efficiency. It's scalable. We all know hardware is becoming an anchor, and your point about you can set it up, tear it down, it scales, all have benefits going forward. But it does require a little more upfront investment.
Upfront investment, dedicated team, and also the mental shift. What we try to show, and I hope I was able to convince, that better compression efficiency, more capability to absorb crazy codecs, and you know how much I love AV1 because it makes my encoder more expensive. But it's a mind shift, and I hope SMPTE will help the video community to first acknowledge, second accept, and third take on these new tools. We give you new tools. We don't want to take your job, but probably as you are Mr. Training and Education, you probably have to educate SMPTE members. This is a journey, but guess what? There are other companies doing it. I'm not going to convince people about what Netflix is doing, how many millions and hundreds of millions subscribers they can manage with 10 engineers. That
Wonderful.
will be my final comments.
And with this, I think the discussion is not the end here, and we'll continue, I'm sure. So thank you very much, Thierry.
Thank you.
Give them a round of applause.